Welcome back to the lecture series on Introduction to AWS. As part of this lecture series, today we will be looking at interacting with an application which is deployed on EMR serverless. So, all these are the topics which we are going to cover in this particular topic, starting with what are the various states of an application, then while interacting with EMR Studio, what we can do. At the same time, when we are going to interact with our application using AWS CLI, what are the various functionalities we can perform. Then what things we can change over when we are deploying an application, that means configuring. And without default settings, we can customize certain things that we are going to focus, how we can customize our EMR serverless image itself. Then what are the other services which can be accessible from EMR serverless using a VPC, virtual private cloud. And lastly, we will be focusing on how we can change the architecture option on EMR serverless. So, to begin with, all these are the states of an application. It begins with creating an application. When the application is being prepared, once the application is created, it is live, the sandbox is live to use, but in this case it is not been provisioned with the capacity. It means that the resources are not going to be provisioned. In starting phase, when you are going to start your application, at that time the resources are going to be attached to your application from the initial capacity. When we are going to launch an application, we will set certain initial capacity of resources. From those resources will be allocated to your application when it is starting. Once the application is in started state, then it means that it is ready to accept various jobs. It might be Spark jobs or it might be Hive jobs. Once the execution of the job is been finished, then it gets into stopping stage where various resources are going to be released from the application once it completes its job execution. Once the resources are going to be released, it moves into stopped state where no resources are going to be running as the resources are released. And once the application is done with its execution of jobs, it can be terminated at the end of the day. So, all these are the various phases or stages in application. Moving further, when we are interacting with EMR Studio, what things you can perform? You can create an application, you can list the available applications, and you can manage the applications to start or stop. So, how to create an application using EMR Studio? Just click on create application, and you have to name your application. The first field which you have to fill is name your application which you are going to run. Then select the type. Type means which sort of application jobs you want to run. It might be Spark jobs or Hive jobs. Once that has been given, then you have to mention the release version of EMR serverless. After that, you have to select the architecture option in step 4, where we are provisioned with two options, ARM64 or base 8664 or bit architecture. Out of these two architectures, you can choose any one in the step 4. In step 5, it will be asking about configuration. You can either go with default settings or you can customize the settings, where you can modify the application limits. It means that what is the maximum capacity of an application, or what sort of resources needs to be allocated at max to an application, or else you can change the application behavior, which comes in with auto start and stop, which we are going to deal with this particular point in further slides, as well as what is your virtual private cloud, that also we are going to deal with. And lastly, once these settings are going to be customized, lastly you can click on create application. So these are the steps which we can perform for creating an application. If you want to list the application, just redirect to the applications page and you can drop down and you can see various applications which are created and is there with the EMR serverless, and you can choose any one of the application to get the details of the particular application settings. These are the things which we are going to do through an IDE, which is a graphical user interface. And you can manage your application status also. If you want to start any application, just click on start the application. If you want to stop the application, you can manually stop an application. At the same time, if you want to configure any of the settings of your application, you can configure if you don't want to go with the default settings. At the same time, you can delete an application manually if that application is no more in use. Next, when we are interacting with AWS CLI with your applications deployed on EMR server, then what things we can perform? One, we can create. Second, we can describe an application. Third, we can list the applications. And fourth, you can delete. Previously, we have done it through GUI, that is through IDE. Now, we can perform the same things through command line interface. In order to create an application, this is a prefix AWS EMR serverless, and create application is the parameter which you have to use, attribute you have to use to create an application, where you need to provide the name and the application type. It might be Spark or it might be Hive, any one type. Then you have to select the release version. So this is the command in order to create an application. Moving further, you can describe an application. If you want to describe an application, then get application is a attribute which you need to use, along with which particular application's description you require, that application ID. To list all the applications in the EMR serverless, the attribute which we are going to use is list applications. At the same time, if you want to delete an application, the attribute which we are going to use is delete application with the application ID, which particular application you want to delete. So all these are the commands which you can perform using AWS CLI. Moving further, if you want to configure an application, then what things you have to know? These are the things which you have to get aware of if you want to configure any of the application which is deployed on EMR serverless. First, you need to understand the application behavior. Secondly, you need to know the pre-initialized capacity for an application. And thirdly, you can configure the default application config. What are the default application configurations which you can customize? In order to know the application behavior, we require to know what is auto start and what is auto stop. Whenever a job is submitted to an application, the application will get into auto start mode. It means the execution of job will be taken over by the application itself, and this is a setting which you are going to enable when you are going to create an application on EMR serverless. But if you don't want to happen that, you can turn off this particular feature, auto start. At the same time, what is auto stop? If an application is not running for 15 minutes, that is, if the application is sitting idle for 15 minutes, then it will think that no jobs are going to be executed and it will stop that particular service, that application. Even this can be configured to the configuration settings, where when an application is stopped, it will obviously release the pre-initialized capacity, but you can change or you can modify the ideal time. By default it is 15 minutes, but you can enhance the time, or else if you don't want this feature, just turn off this feature. Then what is pre-initialized capacity? And then we are talking about pre-initialized capacity. It is nothing but certain resources are going to be provisioned. What are those resources? Such as memory, storage, the IAM permissions, and many more. All these are the resources which are going to be pre-initialized in EMR serverless. So, over here, when you are going to check with the EMR serverless, it provides an optional feature for your applications such as Spark or Hive. These two are going to be having a driver class which will have what to function, and a workers. Workers are nothing but the machines in the cluster. In a cluster we do have workers, and driver will be driving which job should be executed on which particular worker nodes. These are default pre-initialized capacity parameters which has to be provisioned to an application. So, the ideal over here is, if you are submitting a particular job to an application to execute this job, then what this application will do is, it will check for the available initial capacity. If the resources are available, then these resources are going to be given back to the job to get it executed. If suppose the application does not have initial capacity, means initial capacity jobs or initial capacity has been occupied by other jobs which are running, at that moment your application will request for an additional worker nodes where my job can be executed. So, in this case, what your application will do is, it will check what is the maximum limit for an application. If there are resources in the maximum limit, they will fetch the resources from maximum limits, and it will release those workers to the jobs which are going to be running. Once the job finishes its processing, then it will release those resources first which are additionally occupied. And coming to the third part, what we have to know is the default application configuration for EMR serverless. In this default application configuration of EMR serverless, the major two common points which have to know is, one is runtime configuration and monitoring. Such as when a job is getting executed, you need to monitor the status of a particular job, and for this we require the monitoring logs which are going to be stored in some sort of storage mechanism. It might be your RDS, relational database service, or else it can be an S3, or else it can be a Redshift also, any storage service which is provisioned from AWS. So, all the monitoring logs needs to be configured in some sort of storage, not all, any one of the three. So, that we have to know where actually it has been declared and where it is getting stored. If you want, you can override also the configuration settings if required. The fourth topic in this is how to customize our EMR serverless image. So, in our previous sessions we had discussed about Docker. In this example also we are going to talk about Docker, how to create an application, how to convert it into an image, and how to run it in a Docker. So, in this particular topic we are going to consider Docker as one of our parameter. And what exactly we are doing is, we are going to create an AMI image. In short, I can say that Amazon machine image we are going to create, and while creating that image we are going to use Docker. So, the first step over here is, we need to create a Docker file. We need to create a Docker file which has certain attributes. First attribute is from where the base version needs to be extracted. over here from will take an attribute of a particular image which is already there, and this is a this will search in the Docker Hub. In the Docker Hub, the image name is EMR serverless. That is going to be extracted into your Docker container. Then it will create a user with a name root, and when we are talking about Spark and Hive, these are the tools which runs on Hadoop. So I will be creating a user with the name Hadoop and a group. I am initializing it to Hadoop. This is a group and this is a user. I am putting user in a group, and these are the commands or attributes which you have to mention in a Docker file. Wrap it, and once this is done, then just build that particular Docker file. And while building, we are going to use docker build .-t with your account ID for which particular account you are creating this image, and in which particular region this particular image has to be created, and my repository, that is where you want to store the image. These three things are going to be changeable according to our need. Remaining things are going to be intact. Once the image has been built, just validate the image locally whether it is being configured properly or not. You have to see if it is configured properly, then you have to see this succeeded message. If you see this, then your image has been configured. This step you are going to validate whatever image you have created. Once the validation is succeeded, you can upload your image to the ECR repository. For that, first you need to log in into ECR repository. For that, you have to provide your login password and Docker login username as well as Docker password to the AWS account. Once you get logged into your ECR repository, then you can push your Docker image. For pushing, I will be using the docker push command to push the image onto my ECR repository. Once this has been done, that is it. First, download and create the image, build the image, validate and push the image. Next thing, configuring VPC access. VPC stands for Virtual Private Cloud. In this, what we are going to do is, in VPC, we are going to set all the services which are in our requirement of Amazon EC3 to have a storage point. It might be Amazon Redshift, RDS or S3. All these three services are going to be deployed in our own VPC, and all these three are used as an endpoints. Anyone, not all, anyone will be used as an endpoint to store the data in our VPC. By default, when we are getting to outbound rules, because VPC is a virtual private cloud and you require some outbound rule and you require certain inbound rule. When you are going with outbound and inbound rule, it means that within the VPC, from VPC, if you are connecting to the outside world, that is said to be outbound. When you are connecting from a outside PC into the VPC network, then you require inbound rules. By default, outbound connectivity is being given to various services, but inbound connection is being disabled. So you have to provision your inbound rules while you are creating an application itself. How we can create an inbound rules? You have to create an subnets, and that subnet should be private subnets. What do I mean by private subnets? It means that that subnet should not be given an public IP. It should be running on a private IP. It should be running on a private IP, not on a public IP. With what the private IPs are going to be beginning? 172, 192, or else 10. All these are the 3 IP addresses. If an IP address begins with these 3 ranges, then it gets into private IP. And you have to associate the private subnets only, not the public subnets, for security purpose. And from this private subnets you can have connectivity to your S3, DynamoDB, or else your Redshift. And one more thing, security groups you need to manage. For inbound rules, you have to provide, if it is a Redshift, then provide all TCP as an inbound rule. And coming to all outbound rule, it might be all traffic, or else if you don't want, you can go with all TCP also, adding the security group. This is how we can configure our VPC. Next, if you are focusing on the architecture options, as explained, we do have 2 architecture options over here, base 86 64-bit or else ARM 64-bit architectures. Out of these 2, ARM is treated as efficient processor to process your Spark or high workloads. For this, if you want to change from base 86 to ARM 64, if you are going through the command line, then you need to just mention the parameter architecture, hyphen architecture. Remaining things are going to be same: create application, name of the application, release versions, type, and your region are going to be same. Just you have to include the architecture over here to inform, to notify that you are going to change the architecture. And if you are going with EMR Studio, just get into the application and choose ARM 64 out of 2, and you can click on create or update an application. Through GUI, it is very simple, but from command line, you have to run this particular command if you want to shift over. And in both the cases, if you are changing over the architecture, then first you need to confirm the connectivity between your AWS service and your local machine. Second, you need to stop your application. First you need to stop. If you are changing over, then you need to stop the application. Once you had stopped the application, then you can update the application with the new architecture which you want to provision. Once the architecture has been provisioned, you can get the status of the application using get application. And lastly, you can start your application. That's it. Thank you.